Okay, so here's part 2 of the CBA 4 review. All right, so here for number 11, it says we have a county with an area of 525 square miles, has a population of 9,450 residents, which rate, remember rate means we're dividing, best represents the relationship between the population of the county, even though it says country here, I'll get rid of that R, and the area of the county. So we are going to be dividing 9,450 by 525. Now, because we're dividing, and again, we know we're dividing because it says rate, I'm going to get rid of the obvious answer I can get rid of, because if we're dividing, our number gets smaller, which means it can't stay at 9,450. Could be the other ones, but we can't have it. We can't say the number is going to get smaller and then have a large number. It's not how that works. So I know 525 can fit inside of 945 once. That's going to give me 525. That'll be a 0. That'll be a 2. That'll be a 4. And then I have to drop my other 0. Now, this may seem crazy. Because now we need to figure out what 525 times something will get us to 4,200. But fortunately for you, I've already skip counted. So let's go ahead and make a list. We're going to say 525, 1,050, 1,575, 2,100, 2,625, 3,150, 3,625, and 4,200. That's going to be 1, 2, 3, 4, 5, 6, 7, 8. So we know that our answer is 18. Now let's think. Is it 18 square miles per resident? Or is it 18 residents per square mile? Well, we are actually trying to best represent the relationship between population of the county and the area of the county. Population is going to mean people. Another word for people who live somewhere is residents. So our answer is going to be C, 18 residents per square mile. Otherwise, that means every single resident is basically getting 18 miles of land. And if all we have is 525 square miles, that's not going to work. 12 might be the easiest thing we come across in a while. All we're doing is dividing. It says Martha paid $6.35 for 5 pounds of chicken. I wish. That would be a great rate. What is the chicken's price per pound? So we're going to get that $6.35, and we're just dividing it by 5. Okay? When we do this, we're going to see that 5 goes into 6 one time. That's going to give us our 5 and our 1. We'll bring down our 3. 5 goes into 13 twice. That's going to be 10. If we continue to subtract, that's a 3. I'll bring down my 5, and 5 can go into 35. 7 times, I bring my decimal up. That means each pound of chicken was $1.25. I'm going to say per pound. All right. Excellent. Let's move up to 13. 13 is a lot of setup before we can finally look at our answer choices, but that's okay. The table shows the ratio of people who ate a certain type of lunch to the total number of people who ate lunch. A total of 840 people ate lunch. So which statement is true? All right. Well, this one is not that bad. Biggest thing we need to know, how many people? All right. It's saying that 840 people, ate lunch. So I'm going to take that 840 and multiply it. And I'm going to do that for every single one. So for turkey sandwich, I'm going to end up with 840 over 3, which means I have to now divide 840 by 3. 3 goes into 8 twice. That gives you 6. 8 minus 6 is 2. Bring down your 4. 3 goes into 24 8 times. That gives you 24. 0. Bring down your other 0. 3 can't go into 0, so I'll put it like that, which means that 280 people ate turkey sandwiches. Let's do the same thing for vegetarian sandwiches. We should have 840 over 6, which means we're going to be dividing 840 by 6. That's 1, that's 6, that's 2, that's 4. That's 4, that's 24, that's 0. We'll bring down our other 0. There we go. 140 people ate the vegetarian sandwich. We'll do the same thing for the chicken sandwich, but this time we have to do 840 times 4, and then we'll divide by 15. 0, 6, 1, 32, 33. So now we have 3,360 divided by 15. If we multiply straight across, that's what we're getting. So 15 can go into 33 twice. That'll give us 30. We get a 3, bring down our 6. That'll still give us twice. That'll give us 30. 15 can be multiplied into 60 4 times evenly. So that means that 224 people picked the chicken sandwich. For sake of space, we're going to do the salad thing over here. Sorry. So let's do 840 times 7, and then we're going to divide by 30, okay? 0, 28, carry the 2, 56 plus 2 is 58. We're going to get 58, or we'll have this over 30. Quick simplification before we actually divide. I'm going to get rid of my zeros right there so that my division's a little bit easier. Now it's just 588 divided by 3. 588 divided by 3. That's 1. That's 3. That's 2. That's 8. That is 3 times 9. Good God, sorry. 27. That's... let's do it this way. Sorry. I don't want it to look like you can't see it, so I'm going to redo it here. 1, 3, 2, 8, 9, 27, 1. Bring down the 8, 6. So this amounts to 196 people eating salad. So we did the setup stuff, which actually is really important. Now we're going to figure out which statement we have here that's true. It says half as many people ate a turkey sandwich as ate a vegetarian sandwich. Is 280 half of 140? No. So that is completely wrong. 1/4 as many people ate a vegetarian sandwich as ate a salad. Okay, let's find that out. This is how many people ate a salad, 196. They're saying 1/4, 4, 16, 3, 6, 9. Is 49 the same as, what was it? 1/4 as many ate a vegetarian sandwich as a salad? 49 the same as 140? No, that is not even remotely close. So no. C and D we can compare a little bit more easily because they're saying 56 more people who ate a turkey sandwich than ate a chicken sandwich, okay? So all we have to do is find the difference. 280 is my turkey. 224 is my chicken. 7, 10, 6, 5. All right, well, it looks like 56 more ate that turkey instead of the chicken. So far, this works for me. We'll have to do this one over on the side because I need more space for number 13, which is like all of this. Here it says there were 28 more people who ate a salad than ate a chicken sandwich. Here's our salad, and here's our chicken sandwich. Who ate more of what? More people ate my chicken sandwich. So were there 28 more people who ate a salad? No, not even close. Our only answer here is C. When we work on number 14, okay, this is a good one, okay, because we're talking about some ratio stuff here. A flower arrangement has 8 carnations and 24 daffodils. What is the ratio in simplest form, as simplified as it can get, of carnations to the total number of flowers? So let's get to labeling. I have carnations at 8. I have daffodils at 24. How many total flowers would I have? Well, I'm going to get my 24 and add my 8, and that's going to make my total. So now they want to know what is the ratio in simplest form of carnations to total number of flowers. Here's my carnations. Here's my total number of flowers. They want this in simplest terms. So I know that 8 and 32 share a common factor. That's important because that common factor is going to help us simplify. I know 8 can go into itself once. And I know 8 can go into 32 4 times. This is my ratio. Okay. Let's go ahead and go to number 15. All right. So here we just have to be organized when we label to set up our ratio. It says a house painter mixed 5 gallons of blue paint with every 9 gallons of yellow paint in order to make a green paint. Which ratio of gallons of blue paint to gallons of yellow paint will make the shade of green paint? So, blue paint is 5, yellow paint is 9. So we need to see which one of these can simplify to be or have the same ratio as 5 to 9. So if I look at A, is there a factor that can go into 30 and 54 that will also give us 5 and 9? Well, if I'm thinking about factors of 30, thinking about 5, 6, 10, 3, 2, 15. And when I'm thinking about 54, I'm thinking about 9, 6. That's kind of it, honestly, that I can think of. So if 54 has 9 and 6, 30 has 6. So that's going to be my shared factor there. 6 can be multiplied into 35 times. 6 can be multiplied into 54 9 times. So that looks like that matches up. So I'm good. 6 to 10, that can be simplified, but that's not going to be a number that works for us. 10 and 45, I mean, 2 can go into 10 5 times, but 2 cannot go into 45. The only other one we can use is 5, which make that 2, and make that 9. And 2 to 9 is not our ratio. 27 might be the closest because I can use 3, and that gives us 9, and 3, and that gives us 5. But are these the same? So our only answer here is actually A. All right, when we talk about 16, it says Mrs. Flores' sixth grade class has 15 students, 9 of which are boys. What is the ratio of boys to girls in Mrs. Flores' classroom in simplest form? So we know that they have a total of 15 students. We know 9 are boys. How do I find how many are girls? Subtract 9 from my total, which gives me 6. Now, they want to know what is the ratio of boys to girls. Here are my boys. Here are my girls. Boys and girls. Now, they want it to be in its most simplest form. So I cannot leave it like this. 9 and 6 do share a common factor of 3. 3 can go into 9 3 times, and 3 can go into 6 twice. That is our ratio, and that's as simple as we can make it, okay? All right. For number 17. Okay, let's set this up. Said an advertisement for Snackers Crackers claims that 8 out of 10 students prefer Snackers Crackers. Okay? So 8 out of 10 students prefer Snackers Crackers. 8 out of 10. Okay. To all other brands tested. So this is our, I guess, preferred. And this is our total of students. Students. If there were 250 students, how many of them would prefer Snackers Crackers? Well, we've set up our proportion. Let's go ahead and cross multiply. Once we cross multiply, we'll end up with 10. Well, we don't even have to solve because they want to know which one would be the correct setup. So we have 8 over 10 set equal to x over 250. There's only one answer for that, and it's B. Oh boy. Yeah, what's up?
Since Fuji is down, I was wondering if you had like the CBA review stuff.
Yeah. Yeah. It's down for you right now?
Yeah, it's not letting me go in.
All right. Yeah, let me finish this and then I'll get it to you. Okay. Do you want do you need a copy?
You can just email it. Do you have it?
Yeah, I can email it to you.
Okay. Do you have my email? It's just laura.perez.
Gotcha.
Okay, thank you.
No problem. Okay, cool. Awesome. So that's how we find that one. That one's not too bad. Number 18. The table shows the amount of sugar Felicia mixes with each amount of water she puts in her hummingbird feeder. Based on the information in the table, how many cups of sugar should Felicia mix with 6 cups of water? Okay. So, wait, how did I do that? Okay. So this one's going to be a little bit interesting, okay? What I'm going to do here. Okay, so we're going to take... So, I want to find out how much sugar I need to mix up with 6 cups, okay? I'm going to focus on these numbers here because it's basically half of 6. Once I find my answer... Well, once I find my answer, we'll multiply by 6 to figure out what we have. So, here we have 3/4. And I'm going to say divided by the 3, which is over 1. Now, this is a great opportunity for our KCF, our keep, change, flip. When we do this, we're going to keep our first fraction. We're going to change our division sign to a multiplication sign, and we're going to flip the second fraction from 3 over 1 to 1 over 3. I'm going to look for common factors diagonally. 4 and 1 don't share any, but 3 and 3 do, and that number is 3. Multiply straight across, you end up with 1/4. Now, we're going to take that 1/4 and multiply it by 6. Keep in mind that that's always over 1. Now, 6 and 4 share a common factor of 2. That's 2. That is 3. And when we multiply straight across, we should end up with 3 over 2, which of course is an improper fraction. So if I continue to decompose this, well, I'll just do it down here. If I continue to decompose this, I know that I can get 2 out of 2, which is equal to 1. And what I'm left with is 1 out of 2, which is equal to half. Put those together, 1 and 1/2 cups of sugar. All right, let's keep on keeping on. We are almost there. All right, so excellent. So we have Mike and Raymond. They each read the same book, but Mike reads 182 pages in 7 hours, and Raymond reads 168 pages in 6 hours. Based on these rates, which means we're dividing, which statements are true? Select 2 correct answers. Okay, let's do it. Mike is right here, and Raymond is right there. For Mike, he reads 182 pages in 7 hours, and for Raymond, he reads 168 pages in 6 hours. Excuse me. We know 7 can fit inside of 18 twice. That gives us 14. 4, 2, 6. So Mike can read 26 pages in 1 hour, every hour. Raymond, we know 6 can go into 16 twice. That gives us 12. That's a 4. That's an 8. 8. So we know Raymond reads at 28 pages per hour. So now we need to figure out which of these statements are true. Mike reads faster than Raymond. Well, if Mike reads at 26 words an hour, or pages an hour, Raymond reads at 28 pages an hour, Mike doesn't read faster. Raymond reads faster, so that works. Mike reads 2 more pages than Raymond in 1 hour. Well, that's not true. It says Raymond reads 52 pages in 3 hours. Why? That doesn't even make sense. 52 and 3, if you were to multiply that, 52 times 2 is 104 in 6 hours, which is not true. So no. But Mike can read 13 pages in half an hour. Well, let's think about that. If Mike can read 26 pages in 1 hour, then let's split it in half and see how many that is. 2 can go into itself once, and 2 can go into 6 3 times. So hey, 13 per half hour actually works. Awesome. Okay. Here. Obviously, they want us to drag. We're not going to be able to drag, but it says a person burns 90 calories by climbing 18 flights of stairs. Okay, guys, we're going to find a rate. That's going to be 90 divided by 18. All right. Now, let's think about what 18 has to, how many times 18 has to be multiplied by, I guess, to get to 90. I know if I have 18, if I could start with 18, then I'll get 36. Then I'll get 54. Hey, what's up? Okay, then I'll have 72, and then finally I'll have 90. So that's 1, 2, 3, 4, 5. That's going to be our answer here. So that's our rule, okay? Something times 5 will give us our answer. That rule has to stay consistent. So I'm going to write it here, times 5, times 5, times 5, times 5. So now it's just solving. 1 times 5 gives us 5. Something times 5 gives us 15. 3. 5 times 5, that's pretty simple. That's 25. And something times 5 gives us 60. Yeah, it's going to be 12. Good. So that one's not that hard, okay? That one's not that difficult. Now, when we get down to 21, which is almost our last one will be, we have 2 more, okay? But a warehouse has a floor, or a warehouse floor has a perimeter of 72 yards. Cool. The perimeter of that floor is blank feet, and that is equivalent to blank inches. Ugh. Okay, so we need to establish yards to feet, which there is 1 yard to every 3 feet. So we're going to divide 72 by 3. So let's go ahead and do that. 72 divided by 3. And then 3 goes into 7 twice. That'll give me 6. That's 1. Bring down the 2. 3 goes into 12 4 times. Boom. 24 feet. Now, 24 feet, we have to figure out what that looks like to inches. So over here, I'm going to say 1 foot equals 12 inches. And since we have 24 of those feet, we're going to get that 24 feet and multiply by 12 inches to see how many inches that really makes. 2 times 4 is 8. 2 times 2 is 4. Put our 0 down, cross out our 2. 1 times 4 is 4, and 1 times 2 is 2. Add our partial products, and we get 8, 8, 2. Why is that not right? What did I do? Oh, okay, I got it. And then, sorry, my bad. I made a mistake. So I'm gonna get 216. Sorry. 24 times 12. How did I get that answer earlier? Okay, perfect. That's what I thought. Okay, sorry. That's what I thought. My bad. So now, all right, made a mistake. So I have my 72 yards. Sorry. And I need to multiply that by 3. Did I mess up here? Yeah, I did mess up. All right, I'm sorry. My fault. So yeah, 72 yards. I have 72 yards, but it's 3 feet. So I shouldn't have divided. Look, I made a mistake. I'm sorry. I should have gotten my 72 times my 3 feet. My bad. That's going to be 6. That's going to be 201. So that'll be 216. Sorry, y'all. Sorry. Now, because I have 216, that's why this one didn't work out. Same idea. Because I had 216, now I'm going to get that 216 and multiply by 12. Sorry, guys. My fault. So 2 times 6 is 12. Carry the 1. 2 times 1 is 2. Plus 1 is 3. And then that will be 4. Put my 0 down. Cross that out. There we go. 1 times 6 is 6. 1 times 1 is 1. And 1 times 2 is 2. That's going to be 2. That's 9. That's 5. And that's 2. Bam. We found our answer. I apologize for messing up at the beginning. But it also shows us the benefit of writing stuff down, because sometimes we make mistakes, even me. And if I wrote it down, I can catch it. All right. So my bad, but we fixed it. Okay. Number 22. All right. It says Jose purchased gasoline at 4 different gas stations. The total cost of the gasoline that he purchased at each gas station is given below. All right, so basically we're just what are we dividing everything? So that's what we're going to do here. Let's do 45 divided by 10, 4, 40, 5, decimal, 0, bring it down, 5. So, what do you call it? Station W is $4.5 dollars per gallon. All right, let's do X. 51 divided by 17. I know that 17 can actually go into 51 3 times. It's a weird number, but that's how it works. That's going to give me 51. So that's going to equal $3 a gallon. If I do 56 divided by 16, again, I know that 16 can fit inside of 56 3 times. That'll actually give me 48. That gives me 4, decimal, 0, bring it down. 16 can go into 40 twice. Wait, isn't that 3.5? Did I do that wrong? Yeah. All right. So that should be 5, though. I'm doing this one wrong. It should be 3.5. So we'll say that this is $3.5 per gallon. And then, of course, 76. What do you call it? Divided by 19. 19 goes into 76 evenly 4 times. So that'll give us $4 per gallon. So that kind of feeds us into this thing here. Select one station with the highest gas price per gallon and one station with the lowest gas price per gallon. So we're going to find our highest price per gallon, which is W. And we're going to find our lowest price per gallon, which is X. And we're done. All right. Now, for 23, and this is our last one, it's about really conversion and measurement conversions, okay? So we need to figure out the volume of a glass jar is 8 pints. So we have to convert some pints. Well, we have to convert, right? We should know that, I guess I'll write it right here. 1 pint is equal to 2 cups. All right. And so if we have 8 pints, then we can just multiply it by 2. And 8 pints times 2 cups will give us 16 cups. And you could even do that here. If we set up a whole list, we can do 2, 3, 4, 5, 6, 7, 8, right? We can do 4, 6, 8, 10, 12, 14, 16. It works. All right. Now we need to figure out quarts. Okay, we can figure out quarts. One quart equals 2 pints. So again, we can make a little list. We have 8 pints, so that should be 4, 6, 8, 2, 3, 4. So 4 quarts equals 8 pints. Now, when we talk about fluid ounces, okay, 1 cup. Let's see if I can do here. 1 cup equals 8 fluid ounces. So let's see what that means. 8 fluid ounces. So 1 cup. How many cups do we really have? 16 cups, because that's 8 pints. So we're going to take our 16 cups and we're going to multiply it by 8 to get our fluid ounces, okay? So let's do our 16 times our 8. 8, 4, 8, 12. Done. All right, guys, I really hope this helps. Seriously, I really do. All right, I'll see you guys later.